Before moving on, it's worth thinking about trust. A cornerstone of application security is to never trust user input. Some of it could be intentionally malicious. In truth, we should never trust any data in our applications, no matter where it comes from. Data coming from an LLM should be given the same treatment. Assume some of it will be malicious and treat it with care. What does that look like? Here's an example. We've got an application that could be anything: a website, mobile application, even a desktop app that communicates with the server, perhaps an API to handle LLM requests. We shouldn't be allowing client applications to talk directly to the LLM. At that point, we do standard things like making sure the user is authenticated. We also want to limit the rate users can make requests, otherwise those LLM calls could get expensive. Then we need to process that input. Remember that we never trust any input into the application, including user input. That processing includes things like basic input validation, and probably more complex things like detections for harmful content, prompt injection, and jailbreaks. We might also classify the content of the requests. For example, is the user asking about something illegal? At that stage, we prepare the request to be sent to the LLM. That could include specific formatting or templates to help the LLM understand what it should be doing. There also needs to be clear separation between the user prompts and system prompts. Once we're happy with that, we can pass it on to the LLM. In there, we might already have security controls. For example, cloud providers like Azure and AWS have guardrails for their LLMs, meaning they can apply content filters, restrict keywords, and attempt to block jailbreaks. That comes with additional cost, but may be better than doing those things yourself. In security, we like overlapping defenses. So we assume everything so far might still let the LLM generate something bad. We take that response and perform output processing. In there, we're looking for some of the same things. We want to be sure that a jailbreak wasn't used. We want to check for anything harmful or illegal. Once we're happy, it can go back to the client. The client should, of course, still have defenses for things like SQL injection and cross-site scripting attacks. We'll go into more detail on all of those during the rest of the course. Security is all about risk reduction. Earlier, we asked the question, with non-deterministic functionality, should our security also be non-deterministic? The answer to that might actually be yes. Those checks for harmful content, prompt injection, and jailbreaks could be performed by LLMs. Deterministic security controls that we put in place reduce the risk of vulnerabilities. But in theory, they never reduce it to zero. There's always some risk of a vulnerability being present. So if we add some non-deterministic security, then we can reduce the risk of vulnerabilities, and that is what we want. That non-deterministic nature doesn't completely reduce the risk, but then nothing else reduces the risk to zero either. Often, reducing risks comes down to how much the risk is reduced versus the cost to reduce it. So in your application, if using an LLM as part of your security is worth the costs, then it makes sense to use it. Remember that we always want layers to security. I would never advocate using an LLM as your only security measure. There should always be more layers.